Hello everyone. It's been a while since I last posted one of these didactic videos, but I wanted to share with you some of the ideas that I've been working on my last improvs. Specifically, I wanted to talk to you about rhythm and time structuring while live coding with supercollider. Like everything on supercollider, there are multiple ways to address the same topic. Well, here's my approach and the reasons why I do this. At this point, I assume that you already know what a proxy space is and how it basically functions. If not, I recommend you to take a look at my previous videos about live coding. Let me start by giving you a bit of context. Let's start from top to bottom. This page here is my live coding page, and it already has some code in it. Here, we first start by loading the setup file, which basically allows me to start with a blank space. Let's take a look at it. Yes, I push the proxy space, I make a tempo clock, I assign the fade time in seconds, and I set the quantization values in beats per minute. I also boot the server. I load some sound files, Tdefs, and some snippets, and activate a stage limiter, which is good for amplitude values. The sound files, synths, and snippets here, I haven't used them lately, but they're just there just in case. Okay, next I have indicated a tempo, which is here is 110 beats per minute. I created a reverb, which is always helpful to have. And I have designed a series of simple sound sources. They are all named with single letters, and I think they're quite flexible. The reason I have them on my main live coding page is that I can have a panoramic view of both the sound source, I can see what I have, and the arguments that I will tweak while live coding. The creation of each of these sound sources follow my own personal taste, but they basically are aligned within the axis of noisy kind of sound and a more tonal kind of sound. Let's run everything. So the stage limiter is active, which tells us we're free to go. We give a tempo value, the reverb, and let's evaluate these single letter proxies. Nothing is sounding despite the fact that they are playing. The reason for this is that, contrarily to the default setting, the awake method here is set to false, which means that the source will not start immediately. We can, however, obtain sound by using the spawn method. Let's try some. I have some already written. Let's try it with the default values. More noisy. The first one was clearly more tonic, more percussive, and another more tonic. As you can hear, I've deliberately configured my sound sources to be very short. That is so because shorter sounds are less noticeable than longer ones, which can be convenient if during a performance scenario I trigger the wrong source. Nevertheless, all these sounds have envelopes, so their duration can be changed. Actually, all arguments can, of course, be changed. We just need to add parentheses right after the spawn method and insert between square brackets, the arguments, and the new values, all separated by commas. So this was the default A node proxy, and this is with its arguments changed. Again, D, the K. Okay. To illustrate the flexibility or the versatility of the instruments or the sound sources, let's try this A, which is very tonic, with this kind of kick sound. So it's all the same node proxy. Of course, triggering single proxies in the context of a live coding situation won't lead to a very musical result. For that, we need to schedule the sound, and that's where Tdefs come into play. So, what are Tdefs? Tdefs are like routines that can be modified while they are running. We can schedule them to either loop the sound events indefinitely or to allow them to appear for a limited amount of times. Let's do one together. So we create a Tdef. We assigned a name to it, let's say example. And we defined the task. Let's say for 20 times has to perform this kind of sound. And the speed with which it will appear will be every quarter of a beat. So our Tdef here has example as its name, and it's been programmed to repeat 20 times the node proxy A with a waiting time each time of a quarter of a beat. If we run it, we need to play it. Example.play. Here's where things become a bit tricky. If we play this Tdef without specifying any clock, which is the first argument of the play method, let's check it. I have to come here, task proxy, arc clock. If we don't specify the clock, it will use the default tempo clock, which will probably differ from the tempo one has chosen for the music. The default is 60 beats per minute, and we have here set 110 beats per minute. If we go back to the setup file, we can see that I have created a variable t that represents the tempo within the proxy space p. So we can provide t as the argument clock to the play method. So let's play it again without our tempo of the proxy space. And let's play it with. We can see now that by providing this clock here, we pair it with a tempo of the proxy space. So if we let's get rid of the 20, let's do a loop. So if you change the tempo value, the Tdef will change its pace too. Okay, I can stop this. Whereas if we play it here without specifying the tempo clock, we can see that regardless how much we change these values, nothing will happen. Okay. So always bear in mind that to include the clock with which you're working with. This isn't my approach when live coding. And I don't know how elegant this this actually is, or how clumsy this is. But what I've done is to pair a node proxy to a Tdef. So let's say we have it already here. So if we play this sequence, okay. So I'm not entirely sure what exactly happens under the hood. I suspect it has to do with the client versus server thing, because if we inspect what's inside of the sec node proxy, supercollider will tell us that it's empty. But if we pair it, if we run the whole code, this bit of code, I need to, resume this because it's been paused. We can see that it works. So if I change the value of the clock, Tdefs will run faster or slower. Okay, let's pause this. Okay. Important is that play and stop won't work with a combination of node proxies and Tdefs. Instead, we use pause and resume. We just need to bear in mind that the effect of the order will be immediate. If the objective is the Tdef to end after a number of beats, one could schedule its end like this. Let's resume it. We can create wait, so 8 beats. We can wait another 4 and resume, and wait another 4 beats and pause it. Okay, so this is the way we could schedule the end, or how we can play with pausing and resuming. But let's play a little bit with this sequence and see the richness of just by adding this randomness. It becomes more irregular. We can add Okay, you get the idea that it gets more complex as we add, we subtract, we add some randomness. The possibilities become endless. We can always pause it. Of course, we can also do things differently, because one of the most interesting aspects of working with Tdefs is the kind of modular, as you can see, this kind of modular approach. Here we just created I think it is a well integrated rhythmic structure with different note proxies, and we just played with it. From a perceptual standpoint, we will then understand this structure as a unity, and after a few repetitions with its hiccups, we will hear its own kind of rich rich coherence, let's say. This kind of structuring can also be achieved by using patterns, which is something very interesting. For that, we first need to create a variable, which is going to be dur. We're going to do it very simple at the beginning. Let's say this. Important is that we need to include the asStream method, and here right before the wait method, we include dur.next. So we can copy this, and every time, let's say that this one we want to keep this quarter of a beat together, but we can add here here and here. So let's see. We first need to resume this. Now we reevaluate it. And we can stretch it or comprise the rhythmic values. So for like this. Do this. So again, this is another way of structuring the time. Okay. Okay, I think that structuring sound this way allows us to have a slightly more organic kind of approach towards the music. This way we can symmetry and asymmetry, regularity and irregularity have kind of the power of becoming, at least from a improvisational or compositional perspective, both approachable and indispensable parameters upon which the discourse can be constructed. I hope this video was of any help, and I hope to see you, hear you next time. Thanks for watching.